Section 17 of the Science History of the Universe, Volume 1. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Larry Wilson. The Science History of the Universe, Volume 1, edited by Francis Rolt-Wheeler, Astronomy. Chapter 12, Part 2. The transits of Venus in 1874 and 1882 were memorable as the first in which photographic methods and the heliometer were applied, in addition to the older methods of time observation to measure the occasion of contact. The older methods left unavailable the remainder of the transit, but the heliometer made it possible to ascertain the planet's apparent position upon the Sun's disk at any time with great precision. In the transit of 1874, the most elaborate photographic measures ever undertaken until this time were carried out in the United States, where conditions were most favorable. A continuous succession of photographs was made as the planet traveled across the Sun's disk, and various systems of reference enabled its position to be identified with great accuracy at any part of the transit. Yet results were hardly more valuable than those obtained by other methods. Hence, in 1882, the American observers modified their apparatus considerably from previous practice by employing the photographic plate and using the heliostat to reflect the Sun's rays through a telescope lens 5 inches in diameter and of 40-foot focal length. Doubtless better results could be obtained today with modern solar photographic equipment and dry plates. No great advances were recorded as the result of the numerous expeditions during these two transits. Elaborate expeditions were equipped particularly for the second of the two transits, and the observations, which were voluminous, were thoroughly and systematically discussed. The results were a somewhat larger value of the solar parallax, amounting to 8 minutes .857, or rather less than 93 million miles, as obtained by Newcomb after combining the heliometer with photographic measurements. As all measurements of this kind seem to be affected by some constant systematic error, it is the consensus of opinion among astronomers that other methods are more to be trusted in determining the solar parallax than those based on the transits of Venus. The great brilliancy of Venus is due to its relatively small distance from the Sun and the Earth and to its great reflecting power. The albedo of Venus, or the ratio of reflected to incident light, is 0.76. In other words, the planet reflects 3/4 of the light that falls upon it from the Sun, a proportion which is little exceeded by freshly fallen snow. This indicates that Venus is surrounded by a dense and cloudy atmosphere. Similar indications are given by the spectroscope, pointing to the existence of an atmosphere containing water vapor and generally similar to our own, but denser. This atmosphere of Venus, owing to its great refractive power, sometimes appears as a luminous ring in transits of the planet. From observations made at the transit of 1882, it has been computed that the density of the atmosphere of Venus is 1.8 that of the Earth's atmosphere, which produces a refractive displacement of 33 minutes. According to Medler's calculations, the atmosphere of Venus is 1.7 times as dense as that of the Earth. Many astronomers believe, therefore, that Venus is surrounded by a dense atmosphere into which the Sun's rays do not penetrate to a depth sufficient to cause much loss by absorption, probably because they are reflected by opaque clouds. From this it would follow that the markings which have been observed on the disk of Venus through the telescope for centuries may be purely atmospheric. As the displacement of the surface markings of a planet when viewed through a telescope furnish the basis for estimates of the period of rotation, it may be that calculations so made are without justification. These markings of Venus are altogether different from those of any other planet. They are faint, indistinct, and apparently variable, for the drawings of Venus made by different observers before the advent of photography are very unlike. The first astronomer to observe any markings on Venus was Domenico Cassini, who discovered a bright spot in 1666. In the following year he discovered a second spot, from which he deduced a period rotation of about 24 hours, an estimate which was reduced to 23 hours and 22 minutes in Jacques Cassini's revision of his father's work. On the other hand, Bianchini, who studied the planet in 1726 and 1727, deduced from his observations a period of rotation equal to 24 days and 8 hours. Thus began the long and violent controversy in regard to the rotation of Venus. From more than 10,000 observations made between 1830 and 1841, De Vico computed a mean value of 23 hours 21 minutes and 23.93 seconds for the period of rotation of Venus. This value, furthermore, agrees very closely with the period of 23 hours deduced by Schroter from observations of the deformation of the horns of Venus 1 788, 1 793, and it has consequently been adopted in most treatises on astronomy. But in 1890, however, belief in the short period was shaken by Schiaparelli's discoveries. Before this, Schiaparelli had made the surprising announcement that the period of rotation of Mercury was equal to the period of its revolution about the Sun, and he now asserted that the same law governed the motions of Venus, a statement based on observations made in the winter of 1877-78, which showed that the bright spots then visible never varied their positions with respect to the terminator, or boundary line between the planet and its shadow. Observations made in 1895 gave additional support to the view that Venus rotates on her axis in the period of her revolution about the Sun, 225 days, and consequently always turns the same hemisphere toward the Sun, just as the Moon always presents the same face to the Earth. This theory, which on its announcement rested solely on Schiaparelli's authority, soon obtained strong independent support. It has apparently been completely confirmed by the observations made by Lowell at Flagstaff, Arizona, in 1895-6. Lowell saw markings that have been seen by no other astronomer, before or since, but the most surprising thing about his discoveries is that he saw no spots, but only bands or lines bearing a superficial resemblance to the canals of Mars. The whole configuration remained unchanged for hours, which could not be the case if the period rotation were only 24 hours. Furthermore, the markings remained fixed relatively to the terminator. Lowell denies the existence of clouds on Venus, although he finds in certain phenomena of twilight evidence of the presence of a very dense atmosphere. Many astronomers have refused to accept the conclusions of Schiaparelli, Perrotin, and Lowell, and have adhered to the theory of a short period of rotation. Schiaparelli's first announcement was vigorously disputed, soon after its publication, by the French astronomer Trouvelot. During his residence at Cambridge, Massachusetts, from 1875 to 1882, Trouvelot pointed out 17 changes in the markings which Schiaparelli regarded as fixed. Trouvelot regarded the bright spots on the limb of the planet as very high mountains rising above the atmosphere. The observed changes in the appearance of the horns of the crescent planet have also been ascribed to mountains. In the 18th century, Schroter announced the discovery of several mountains on Venus. In 1789, the southern horn of the crescent appeared blunted, and near it on the dark disk of the planet shone a bright peak, the height of which was estimated by Schroter as 117,000 feet, or 22 miles. Trouvelot deduced from his own observations a period of rotation of about 24 hours. It is very remarkable that two such experienced and trustworthy observers as Schiaparelli and Trouvelot could be led to such widely differing results from their frequent observations of the same object during the same period. It may be regarded as certain that the problem of the rotation of Venus cannot be solved by observing markings, which is not surprising if they are purely atmospheric phenomena. Sir William Herschel, who has justly been called the greatest observer of all time, doubted the reality of the markings of Venus and regarded them as atmospheric phenomena. But this view was not shared by any of his contemporaries. Beer and Mädler, who were also most excellent observers, studied Venus repeatedly in 1831 and later years, but they rarely if ever saw anything that deserved the name of a marking. Attempts have been made to solve the interesting and difficult problem of the rotation of Venus with the aid of the spectroscope, but these attempts have also failed to give a positive result. The effort was first made by the Russian spectroscopist Jelopolsky at Pulkowa Observatory. The spectrophotographic measurements, which were begun in 1900, indicated a short period of rotation. Although Jelopolsky did not regard the correctness of the result as assured, his authority led to the belief that the spectroscope had decided the question in favor of the short period. Then Lowell, who had deduced a period of 225 days from telescopic observations, sought confirmation for this value by the spectroscopic method. He first tested his new and delicate apparatus and method by applying them to Mars, and obtained for that planet a period of rotation of 25 hours and 35 minutes, which agrees fairly well with the known period 24 hours and 37 minutes. For Venus, Lowell's spectrophotographs give a rotational velocity of from 5 to 8 meters (16.4 to 26.2 feet) per second, which corresponds with a long period of rotation, though one much shorter than 225 days, for which the equatorial velocity would be about 2 meters (6.56 feet) per second. Neither of the results obtained at Pulkowa and at Flagstaff has yet been confirmed elsewhere. The spectroscopic method is too difficult to be attempted except by a particularly well-equipped and favorably situated observatory. The theory of slow rotation receives powerful support from certain arguments advanced by the distinguished English astronomer Sir George H. Darwin. The rotational velocity of every planet must be gradually diminished by tidal friction among its parts. In this way the period of the Moon's rotation has been made equal to the period of her rotation about the Earth, and the rotational periods of Mercury and Venus may have been similarly lengthened to equality with their periods of revolution about the Sun, which exerts a far greater tidal action upon these inferior planets than upon the Earth. If Venus has already reached this stage, all the water on the planet must be accumulated in the form of ice on the dark and intensely cold hemisphere. Hence, as Antoniadi has pointed out, the presence of clouds and water vapor on the illuminated hemisphere casts grave doubt on the correctness of Schiaparelli's theory. The presence of clouds in the atmosphere of Venus is denied only by Lowell, who saw the peculiar canal-like markings distinctly whenever terrestrial atmospheric conditions permitted. No trace of markings, by the way, was seen by Hansky and Stefanik, who studied the planet in the summer of 1907 at the Mont Blanc Observatory, which is more elevated than Flagstaff, under very favorable atmospheric conditions, and deduced a period of rotation slightly less than 24 hours. So the problem of the rotation of Venus is still unsolved, although a majority of astronomers appear to share the view of Schiaparelli and Lowell. The hope that it can be solved by observing markings has proved illusory, and there is good reason to believe that the spectroscope will ultimately furnish the solution. Venus, in size, is almost identical with the Earth. Its diameter, expressed in miles, is 7,800, as compared with 7,920 for the Earth. Its circumference consequently amounts to 23,400 miles, as compared with 25,000 miles that of the Earth. The period of revolution around the Sun is 225 days. For many years observers have been looking for satellites of Venus. Fontana (1645), Cassini (1672 and 1686), and Montaigne (1761), among others, imagined that they had made such a discovery, but these have for many years been considered optical illusions. Section 18